wrong outside. Yeah. All right, so let's go with the first one. The graph shows 4 right triangles. Use the graph for exercises 4 through 7. Which two triangles, which two triangles are reflections of each other across the x-axis? What is the first thing you want to do here? Highlight the x-axis. Perfect. So you want to go over here and highlight the x-axis so that you know which axis the images will have to cross. This gives you a better idea because your eyes kind of fold the pictures together, and now you can very easily tell which ones those are, right? Which triangles are those? A and C. Triangle A right here and triangle C. So we're going to do that for triangle A and triangle C. Those are the ones that are reflections of each other across the x-axis. The next one. For which two triangle is the line of reflection the y-axis? So what do you do here? You go and highlight the y-axis, right? With a different color, exactly. And now you can easily tell which one of those. If you notice, as you highlight, your eyes kind of go in the middle, and as soon as you get to it, it kind of warns you that's where they are. Because right here at the top, it makes no difference. But once I put my finger right here, I can already tell that I have the same thing on both sides. It's kind of cool. That's the main reason why I want you to do it that way. Why I want you to highlight it, because you find your answer that way visually. So it'll be C and D, right? Triangle C and triangle. The what? Well, if you line means a line, a segment, a measurement from one place to another. Do not put that. You only use them when you're talking about lines, segments, or a side. But we're talking about the actual triangle. If you put just A and D, that's fine. I mean, A and C, that's fine. Or C and D, that's fine without the little triangles. But from now on, I want you to use those things. Yes. The what? Do you understand why? Can somebody explain to her why her answers are flipped? But they're not correct. Yeah. Translation. No, she says that she got these two flips. Yes. Most likely, right? She probably got her Y and her X. The X tells you where it is. The Y tells you where it is. Yeah. For the fourth, let me read the question again. Which two triangles are a reflection of each other across? Meaning they have to be across the x-axis. X-axis, meaning this one right here. Which means they have to cross this entire yellow path. Well, which one of them are crossing? They're on the same side. No, they're crossing the Y. This one crossed the Y to get to that one, right? The C crossed the Y to get to the other position. But that's not right. You're not crossing the Y. It's asking you to cross the X, right? That means you have to cross this axis. Which one is crossing that axis? Is anybody else confused with that one? Yes. Mm-hmm. But you have to cross that axis, though. The image has to cross it. All right, so which triangle is a translation of C? B. A change of position, but it does not change the shape. D is flipped. They're asking about translation, right? So if you look at it, Let me erase all this madness. But they're not translation. What is a translation? Sliding, right? You're just sliding. Look at it. If I grab C and put it and slide it towards D, does it look the same? No, that means you did something else. You did not only translate it. If you go up and put it on top of it, what happens? Does it look the same? It doesn't, right? However, like she said, you just grab C and you can almost slide it up and put it on top of B, and it'll be right in the same position. You can easily match it. Exactly. Translation, you slide, reflections, reflect. And you notice that A and B are reflections, right? Which means that B must be the only translation there. And now, can somebody explain to me what kind of translation is it? What was the command there? What happened? Yes. 6 units to the right and 8 units up. This means that this went 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6, 7, 8. Good. And then this will be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Yep. And from here to here, and then from here to here, right? Is there another way to get the shape up there? 8 up and 6 the other way, right? So I can go this way, oops, and then that way, and then this way, and then that way, and then, oops, that's not it. What did I do? That's where it is, right? Lame. Okay, so right here, and then right there. That was the other one. And then from here to here. Now, I have a kid who asked me this question. Well, what would happen if we have two routes on the test and they were talking about a city? This is the question that he asked me, Diego. And then he goes, what if it's the streets? And they ask you, which one are you going to use? They give you the answers as 6 to the right and 8 to the up, or 8 up and 6 to the right. Some kids, that's exactly the same thing. Other kids said, no. On the red one, you go into the right first, and then you go in up. On the green one, you go in up first, and then you go into the right. So then I asked the kid what his question was, because I wasn't sure. He goes, I'm saying, what if there's an obstacle? That's what he said. And I'm like, what do you mean an obstacle? Like in the way. What if there's like a big puddle right here, and you can't get through it? Then which one's the right answer? The black one, right? Because there are no obstructions there. You can go to the right first and then go 8 up. And that was something that was not part of the lesson. It was not part of the thinking. But he came up with the problem on his own, and it was a really good problem. So I thought I was going to share it. But that is a good way, in case you ever see that. That is a good way. And that's basically how maps work. If you think about it, your maps are automatically updating traffic, and it'll reroute you according to that. There are many different ways to get to the same location, but you go by the one that doesn't have many obstructions. So it was really good. So we already described the translation. Which triangles are congruent, and how do you know? Let me erase all this madness so that you can see better. Micah. You could say that, but what are you basing off the size and the shape? I'm sorry? I'm asking you, how can you prove to me that those are congruent? You can measure by the cubes, yeah, like by the squares, and say, all right, the side lengths are the same. If two side lengths are the same of a triangle, does that mean that the other one has to be the same for all of them? Pretty much, yeah.
If you flip the shapes according to C, let's just say we flip them the same side C is, and you put them together, they would be aligned.
Okay, so C and D, if you match them, they will be exactly the same, right? What are you gonna say? Yeah. So again, you can justify the same size by what Micah said, counting the squares, right? And the same shape because they're triangles. Yes. Same slope. Yeah, you can say that too. Because if you match them, you don't have the exact same slope. Yes. Good. All of them are good. But this is what I was actually looking for, which is a little more specific. It's basically what you said, but more specific. One kid said, Denise actually, Gutierrez, not Servin, she said, well, I can say that they're all congruent because A is a reflection of C. D is a reflection of C. And B is a translation of C. If A is a reflection of C, then that means A and C are exactly the same, right? If D is a reflection of C, then that means those two are exactly the same. So right now I know for sure that all three, A, C, and D are the same. And the last one is that the other one, I moved all the points up and all the points to the right at the same time, which means that those are exactly the same. That is a really perfect way of explaining congruency, because generally when somebody says congruency, they said same shape, same angles, same size. But you can't see much of that here, right? Yes.
Okay, so you know how would you use translation when rotating a shape? Because earlier today we were doing that, and would it involve like translation also?
You can have multiple, and you will find that in the next part. There is a part where you probably have to rotate to match it. But you can have a translation and a rotation and sometimes a reflection to get to the image that you want. So I just want you to explore these ideas. Okay, do we have any questions on that part? So we explain why they are congruent using not the same shape and not the same angles only, but also the fact that they are reflections of each other, they are exactly the same, right? If they are a translation of each other, then by definition, they are exactly the same. When it comes to transformations, know this. For translation, rotations, reflections, I think that's it. Now, for those three, the figure stays exactly the same. The only one that changes is dilation. Can you tell me why?
It grows.
Thank you. It grows or shrinks. In that situation, then what are the shapes? If they're not congruent, what are they? They're just similar, right? Dilation means that they increase or decrease, like your pupil. Remember that?
Oh, I got it.
Yeah, you dilate your eyes.
But there's too much time.
Yeah, the size of the change of the shape changes only the size though. When you dilate your eyes. Yeah.
The dark liquid.
All right. For the next one, graph the quadrilateral, which is already on there. On the same coordinate graph grid, graph quadrilaterals W, X, Y, Z prime, the image of the quadrilateral W, X, Y, Z after the reflection across the X axis. I'm going to let Tabaria answer this for us. Tabaria, what are we reflecting across? The X axis. Where is the X axis? On the grid. I'm sorry? And here? From left to right, correct? So this is the x-axis, and in case for whatever reason you get confused, I can almost guarantee you that you will always get it written right there. It's going to tell you that's the x-axis. So if we're reflecting across the x-axis, what do we do with those points?
You translate
Tell me what you did with the points on that situation. Uh-huh. Down. Okay, I see what you did. What is the more precise way of doing it? An easier way. We're not translating, we're reflecting. Yes? Exactly. Count the points actually away from the x-axis. Count the points away from the x-axis. So it is 1, 2 points, right? W. And it should be exactly the same distance on the other side, correct? So that will be 1, 2. It should be right here. And you don't have to do much counting of going up and down. You only go in one direction. So what would this be called? W prime, not Y. What about Z? What would it be? But where is it? 6 up, right? On the same line. So it'll be right here. And we call it Z prime, right? What about Y? 1 right across, right? And it's Y prime. What about X? It comes down, right? X prime. That's very important. You need to understand that a shape isn't always in one quadrant. Sometimes it's in more than one quadrant. You just need to understand that you're still flipping across, no matter where it is, in the same distance. So now I can go over here and I can create the new shape. There we go. And it's a direct reflection of the first one, right? The pre-image. The what? Kind of does too. Looks like a big butterfly. All right. Which side of the image? Let me stop right there. They said the image. Which one are you talking about? The green one, right? The one with the prime numbers. Exactly. The image is congruent. What does that mean? Exactly the same, right? As the line, the side YZ. Let me highlight YZ so I know what I'm talking about. So which one is the same as that one? Yep, Y and Z prime. All right, name the 3 other pairs. So these 2 are the same thing as these 2, right? And that. Oh. Those are not congruent. So we know that these 2 are congruent. But remember, this is not translation, this is reflection. So which one goes with WZ over here? Which one goes with WZ? WZ prime. It's exactly the same letters, just prime. Because we reflect it, remember that. They maintain the same format. So it should be these right here. And how about, no, because we're talking about 2 different sides. WY is one side, but when you reflect it, it should stay the same side, the same letters, right? That doesn't change. The letters do not change. Don't forget that. So WZ will be WZ prime, right? And then the last one, I'm going to use red. XY should be XY prime. And now that you do it that way, you can see that they're a reflection of each other, kind of. I wish I could just rotate the entire thing. All right. We did. All right. Which angle of the image is congruent to angle X? Where's angle X? Right here, right? which angle is congruent to angle x? Angle x prime, right? Just like when looking at the sides, the letters don't change. The prime changes, but you still keep the same thing because they stay true to the properties. Nothing is changing, right? All right, good job. Good. So now let's go. Well, that will be the same thing. We just count the other ones. All right, hang on a second. So let's work on the back part of this one, and I want you to do this on your own, and do letter A, B, and C. I will give you about 5 minutes. All right. This should be fairly easy. Fairly. That's the keyword. So let's take. I didn't complete the whole thing. Let's take it over here. Okay. It says graph the image on the figure shown after a reflection across the y-axis. What are we reflecting across the barrier? This one, right? What does that mean, Kayla? Uh-huh. Which way are you going? To the right, right? You're trying to cross the y-axis. What is the easiest way to do that? Count the units away from the y-axis, right? And do it on the other side. 1, 2. So it should be right here for the next one. 1, 2. Use a different color. Right here. And that one is 5, so it should be 5. That one is 4. And the one on top is 3. And the one over there is, oops, right here. Messed that one up, sorry. So now we can connect them, right? Let's make it blue. There we go. It doesn't look perfect, but you get what I mean. All right, on the same corner grid, grab the image of the figure you drew. Let's stop right there. Which one is the image? The blue one, right? So in part A, yeah, but that's the only image we have, right? After a reflection across the x-axis. Where are we crossing now? Now we're crossing the x-axis. We're going to go back over here and highlight the x-axis to tell us we have to cross that thing. We are recording. So now we're going to cross it over here, do the same thing. This point is 1 away. The other one is 2. This one is 2. This one is 1. This one is 5. And that one is 5. So I can connect the dots, and I end up with this, right? How many of you got that? Awesome. Okay. All right. So make a conjecture. What other sequence of transformations, meaning translation, rotations, and reflections, would produce the same final image, meaning the green one, the last green? I should have done it in red. I'm gonna do it in red. Would produce the final image, which is the red one, from the original pre-image, which is the green one. Translation and rotation, right? So I can translate the green one to move this way exactly as it is, and then maybe move down exactly as it is, and then at a point, rotate, right? And then I will end up with the same image. That's pretty cool. Do what? Yes. Well, we're not looking about, we don't even actually care about the blue one. We're concerned about, yes, the red one is the final image. Yes. You can go. Yes? Uh-huh. Mm-hmm. Well, that's exactly what we did. We reflected across the y, and then we reflected across the x. And that's how we ended up with the second one, with the last one. That's what we did. But they were asking you what are the other ways that you can actually get to the last image without reflecting, but just other transformations. So yeah, you can slide it, which is to translate it, and then translate it down a little bit, and then rotate it 180 degrees, as Alyssa said. And then you will get it right on the opposite side. Good. Do we have any questions on those? How do you feel about reflections and translations? 5, I totally got it. 1, I'm not so good. Too easy? Yeah. Somebody has a 3. Talk to me. Tell me what's bugging you. We have not covered rotation. That was just an additional part. Don't worry about rotation. We have not covered it yet. It's in the next chapter. So either way, go back to the video, and this should be able to help you. For this one, I want you to work on it for the next 5 minutes, and then I'll explain later on. Let's go. So this one is telling you to graph the triangle DEF, which is already there, and it's already giving you the points. So for those of you who graphed it and you didn't line in the same place, that means you don't know how to plot points. It's not good. Next, graph the triangle DEF prime, the image of the triangle DEF, after a reflection across the y-axis. So we're reflecting across the y-axis, right? That means we have to end up on the left side. And D is 2 away, so it should be right here, D prime. F is 5 away, so it should be right here, E prime. And this is 5 away, and then F prime. And now you can connect the dots, right? There we go. On the same coordinate grid, graph triangle DEF double prime. That means you have the prime and then you have a double prime, a second one. After the translation of 7 units down and 2 units to the right. This is easy, right? All you have to do is grab it and move 4 units right. Grab this one and go how many units down? So here. Yeah. And how many to the right? 2 to the right. So that's 1 point. And the other one is 7. So it's right here and 2 to the right. And the last one is 7 right here and 2 to the right. So I end up with points here, here, and here, right? Which should be able to connect. That means this will be double prime, D double prime, and F double prime, right? Because that is the second transformation we did with the pre-image. Is anybody confused? No? Are we good? This is just translation. Yes. Okay, good. I did. You see the little arrows that I drew? That's what they were. You can grab any point that you want. I'm going to use this pen because it's more colorful. I'm going to grab this point, right? And I'm going to go 7 units down. 1, 2, 3, 4, 5, 6, 7. And it says 2 to the right. 1, 2. I end up right here. any of the points. Any of the points. I could. From here? No, you only. When do you do that? When do you actually count from the x or the y-axis? When you reflect, right? When you reflect, but you're not reflecting. You're translating. You sliding. And by the way, for reflecting, they don't tell you the units. They just say reflect across the x-axis or the y-axis. For this, they do tell you. Uh, one little thing before we move on, is that I have to show you a different way. That is one way of doing it. The other way is by finding the coordinate points. So this one would be -5 and 6. Point F is -5 and 1. And this one is -2 and 6. When you're moving up and down, where are you moving? On the y-axis or the x-axis? Y-axis, right? If I'm going up, am I adding or subtracting? Adding. So if it says 7 units down, that means I'm subtracting 7 from all my y values. So I will subtract 7 from, let's put it over here. Where are my y values? Right here, right? If I'm going 7 units down, I'm going to subtract 7 from all my y values. So 6 minus 7, what do you get? -1. 1 minus 7? -6. 6 minus 7, the same thing, -1. And then he says 2 units to the right. Which one goes to the right or left? The x, right? Because I'm going to the right, I'm going to add 2 units to all my x values. So -5 plus 2, -3. -5 is the same thing. And -2 plus 2, 0. So these should match my new picture. -3 and -1. -3 and -1, yep. -3 and -6, yep. 0 and -1, yep. Well, sometimes I'm just going to give you the numbers and you have to be able to do it. So this was just an intro to that. Yes. No homework.